Thanks so much. Hi, everybody. Can y'all hear me in the back there? This is working? Okay, excellent, excellent. Hi, welcome. Isn't it lovely to be inside this nice, warm, dry conference room instead of out in the blustery rain? My name is Anjana Vakil. You can find me on Twitter at my name because I am not good at coming up with clever, cute internet handles. And the slides for this talk are up on my speaker deck. You can find it at speakerdeck.com/vakila, and then the language of programming talk, in case you want to look at any of the references, which are all listed in the end. And the talk I'm here to give today, and hopefully the discussion that I'm here to open with all of you, is about the language of programming. So I'm a software developer and educator. I'm based out of San Francisco. And like many of us in the industry, I do not have a background or a degree, a formal education in computer science. Instead, I came to know and love the field of software development through the fields of linguistics and computational linguistics. So my background is in studying linguistics, which is the scientific study of human language. And before I studied that, I studied philosophy. So I really like to get into these big, huge philosophical questions like, what even is code, man? And I kind of laugh at myself and make fun of myself, but I think it's really important that we do this from time to time, that we kind of take a step back and then we consider, what are we even trying to do here when we sit down and type these weird invocations into our computer that then magically executes whatever we've told it to do. And so I think that it's probably not very controversial to say that code is somehow related to language, right? We use the word language when we talk about programming languages. We use a lot of linguistic type metaphors when we talk about code. So I don't think it's really going too far to say that it's somehow related to language or some type of language. And I used to think that it's kind of a language that we use to talk with machines. Unlike human language that we use to talk to each other and to communicate with other humans, we use programming languages to communicate between me, the coder, and my computer. So here I am over here smiling because I've just had a brilliant idea. And all I have to do is write down those weird magical invocations in some programming language, save it to my 3.5-inch floppy disk, insert that into the drive in my laptop that I definitely have. And then magically, my idea comes to life. The computer does whatever I told it to do. That's pretty cool. And so I used to think that this is the kind of flow of information, that I am using this programming language to talk to my computer. But recently, I've started to wonder if that's actually even the case. And this is a question that's been raised for a long time by lots of folks, is really communicating with machines the primary purpose of programming, of writing code, of developing programming languages? And a lot of folks say, no, it's not. That's kind of a nice side effect, but really the core purpose is for us to talk to other humans through the medium of our code. So folks might be familiar with SICP, Structure and Interpretation of Computer Programs, really epic introductory programming text out of MIT. And in this great book, one of the many fabulous quotes is that they say, a computer language is not just a way of getting a computer to perform operations. In fact, it's a novel formal medium for expressing ideas about methodology, about how we want to solve a problem. And so thus, they say, programs must be written for people, humans, to read, and only incidentally for machines to execute. So the primary purpose of us writing this code is really to communicate our ideas about the methodology we're using to solve a certain problem to other people. And then, as an added bonus, we get the computer to actually run through that methodology. So really, we can think of coding not just as language for machines, but first and foremost as a language we use to communicate with other humans about doing things with computers. So instead of this kind of one-way flow of information from me to the computer, instead, what we start to see is a really collaborative pattern where I have some idea about how I want to solve a particular problem in a very structured, methodological way. I encode that in a formal notation in my program, in my code, which then my teammate across the room, or perhaps some complete stranger across the world who checked out my GitHub repo, can read and understand my mental model, understand my ideas that I want to have the computer do, because that's how I'm trying to solve this problem. And then both of us can work on that code together, kind of sync our mental models. We can collaborate, we can share our ideas, encode them formally in this program, which serves not only as a communicative medium between us, but then, lo and behold, we can, again, put on that floppy drive and give to the computer to actually run through in a way that we have specified collaboratively. So this is really, to my mind now, kind of the very, very powerful thing about code. It allows us to collaborate. And in that sense, it's very similar to human language. Human language is so epically powerful because it allows us to communicate with one another so that we can collaborate on whatever endeavor we have in mind, whether that be hunting a woolly mammoth or whether that be doing something completely audacious like building a tower to reach heaven. So if folks are familiar with the story of the Tower of Babel, the idea being that imagine a time when all of humanity spoke a single language. Imagine the collaborative power that would give us. We could all work together, all of us, and direct all of our forces towards a single project. For example, building this really big tower all the way up to heaven. And in the story, it goes that was so threatening, apparently, so dangerous of a possibility that even an omnipotent being, God, would feel like that might be a threat, and so decided, as the story goes, to split up human languages so that we would no longer all be able to understand each other and undertake such audacious feats. Now, that is not the current accepted origin story of all the world's different languages in the linguistic scientific community. As I said, linguistics is a science of language. And this is not exactly how they think we got all the different languages that we have today. They think it has a lot more to do with how we kind of evolved and moved around as a species. But one way or another, we ended up with a bunch of different languages on this planet. And so linguists seek to try to understand the phenomena of human language by looking at each of its many different faces. And today we have something on about 7,000 different languages spoken and used on the planet. And so each of those 7,000 languages is a crucial piece of the linguistic puzzle. So linguists really value every single data point, every single language that they can study, that they can understand, that they can record, as a crucial element of the global, overall picture of how language works for humans. And so the field of linguistic typology seeks to analyze different languages and understand how they compare and contrast in terms of different features that those languages might have. This is a map from a really cool project called the World Atlas of Language Structures. And if you're ever curious about how different features, whether that be features of the sounds of language or features of the grammar and the syntax of different languages, how those compare globally, definitely check out this World Atlas of Language Structures. It's a really cool project where they break it down on lots of different levels. And this particular visualization, what we can see is a subset of the world's languages, just a few hundred, about 300 and some, with the different colored dots representing different ways that these languages handle a particular feature, or whether or not they have a particular feature. In this case, we're looking at a grammatical feature, and in particular, the feature we're looking at is whether or not the language has gender distinctions in personal pronouns. So English, for example, has a gender distinction, he, she, they, and singular pronouns, but we don't have that distinction in I, or you, or we, right? And what we can see through doing an analysis like this, which is so nicely visualized here, is that even if many languages share the same way of handling a particular phenomenon, so many languages might share a particular feature, there still might be a handful, or in some cases even one language, that does something typologically different. And that is a really valuable piece of information. All of these pieces of information are valuable. For example, there's only one language in this study where they have distinction in the third person, but not in the singular, only in the plural. So it would be like she-all and he-all or something like that. And as we can see, there are various other ways of handling this phenomenon. One other interesting thing to note here is that the vast majority of languages in this study, 250 out of 300 odd, don't make any gender distinctions in pronouns at all. So it's almost, looking geographically, it's almost like that's kind of a largely Western phenomenon. Just going to point that out without further comment. Anywho, the point is that to do linguistics, linguists really need to take a look at all of these data points and consider them globally, and all of them are equally valuable for understanding the overall picture. And so what they will do is they will take a particular language and deconstruct elements of that language to try to understand the composition that makes them up. So one level of analysis that they might do this on is syntactic analysis, so understanding the grammatical structure of phrases and sentences. This is a sentence you might have heard before: colorless green ideas sleep furiously. Anybody recognize it? Couple hands. So this is a sentence made famous by Noam Chomsky in his seminal and very influential work, Syntactic Structures, a book that came out in the 50s, 57, I believe, where he kind of started linguistics down a path of really paying attention to syntax a lot and to composing or understanding how sentences and phrases are composed of these constituents, these grammatical constituent phrases. So here we're taking this sentence, which is an example of a sentence that's syntactically valid, so grammatically okay, but semantically, in terms of its meaning, it doesn't really have any. It doesn't really make sense. Colorless green ideas sleep furiously. Not really a sentence you would expect anyone to say, meaning-wise, but grammatically it's perfectly fine. And we can show that by showing how it breaks down into a noun phrase and a verb phrase, and how each of those phrases further break down, perhaps into subphrases, and ultimately into individual words with different parts of speech, adjectives and verbs and nouns and adverbs. And so this is one way that linguists might try to deconstruct language to understand the underlying phenomena. And this is just one level of analysis that they might do that on. They might do it on many other levels of abstraction, both higher than the sentence, so things like considering entire texts or considering entire dialogues between people as conversations, and understanding how conversations break down and how texts break down in terms of the discourse used. Or they might look on a lower level. They might look at individual words and how those break down into sub-word units of meaning called morphemes. Or they might look at the level of sound. How are the sounds of a word broken up into syllables? How are those broken up into individual sounds called phones and phonemes? And the point is that they will need to kind of look at different levels of analysis to really understand the full picture of how this language works. Now, this reminds me a lot of the type of work that we do as programmers. We analyze our programs and break them down on different levels of abstraction, much like linguists do language. So we look at, on the big picture, we look at our systems in terms of their components, their services, microservices, things like that, and how all of those pieces tie together. We also sometimes look at an individual module of code and understand how it's broken up into functions, if we're doing functional programming perhaps, or objects, if we're object-oriented programmers. Or sometimes we get much, much lower level, and we think about the individual instructions that the computer would have to execute here, or how all of these commands might break down into the individual bytes and bits that the computer is actually able to speak, as it were. The point being, in both of these types of analysis, linguistic and software analysis, when we do this type of deconstruction, when we look at how our programs or our sentences are composed, we are relying on certain structures that are not objective things in the world. They're all parts of a theory that we have about what types of structures exist, or in some cases should exist, in a language or in a program, and which ones are most important to pay attention to. So for example, Chomsky, in his syntactic structures, placed a huge emphasis on looking at the phrase level of the way sentences break down, so this syntactic analysis, and posited these kind of trees and said that this is how all language works. It works really well for English, but it also made some assumptions that other linguists disagree with. So this is a quote from a linguist named Michael Tomasello from a paper he wrote called "Language is Not an Instinct," that was a response to a book you all might have heard of called The Language Instinct by another linguist, Steven Pinker. What we're getting at is like this epic war in linguistics that rages to this day between the kind of Chomskyan Pinker tradition that posits kind of that language is this innate thing that we all have this innate structure for in our brains, and there are terms like universal grammar thrown around, and we're not going to get into it, unfortunately. And then there are other folks like Tomasello who take kind of more of an approach of understanding language in terms of general cognitive function and how humans approach cognition more generally, language as being kind of a subset of that. This is all to say, there's this kind of fundamental disagreement in terms of what the structures are that we should be paying attention to. And one thing that I really like in this paper by Tomasello that he points out is he says that there are no theory-neutral structures in linguistics. You can't say that noun phrases exist objectively. That is a theory you are using to apply to do this linguistic analysis. It's not a be-all, end-all thing in the world. It is a theory. And there's no way to do any kind of linguistic analysis without assuming some kind of underlying theory, some kind of worldview of how language works and how it's broken up. And this is true in programming as well. When we look at a system and we try to understand what are the units of analysis here that are most meaningful, that are most important for us to pay attention to, we are assuming an underlying theory or worldview, you might say, of how programs are composed, what types of things they're made up of, how those things behave and interact. And we have a word for that type of theory or worldview. We call it a paradigm. A programming paradigm is a really fascinating topic that I could nerd out about for an entire hour, and in fact I did at this conference a couple years ago. So if you want to nerd out with me about programming paradigms, you can check out my talk, Programming Across Paradigms, from GOTO Chicago 2017. But I won't talk your ear off about it now. I will just say, however, that it's really interesting to consider how our tools, our programming languages, support or do not support different theoretical constructs for what a program is or could or should be. So this is a diagram from a paper by a researcher named Peter Van Rooij. He's a computer scientist who researches or has written a lot about programming paradigms and how they relate to problem solving, which is what we're trying to do here as coders. And he says that every language realizes or supports, we could say, one or perhaps multiple paradigms. So you might have some languages like Haskell, let's say, that force you to use a particular paradigm, functional programming in that case. Or you might have other languages like, let's say, Python, that are much more flexible, that allow you to write imperative code or object-oriented code or even functional code, and so on and so forth. But he started looking at those paradigms and trying to deconstruct them even further. And he posits that each paradigm can actually be understood as a collection of concepts that it supports. For example, does this paradigm allow state? Does it allow non-determinism? And so on and so forth. So these kind of fundamental building blocks, these questions that a paradigm has to answer, which when you take a bunch of building blocks and put them together, you get kind of a theory of how a program works or should work. And he says that insofar as it supports those different concepts, each paradigm makes the best solution for a particular type of problem. So we can't understand paradigms as good or bad objectively. And by extension, we can't understand the languages that support those paradigms as good or bad objectively. Rather, we have to understand them in the context of a particular problem. Is this a good tool for solving this problem? And what this brings to mind for me is another word from linguistics, and perhaps one of the like linguistics 101 like main ideas that you learn when studying this is to avoid prescriptivism. Prescriptivism, or a prescriptive comment about a language, would be saying how language should be, versus a descriptive comment would be saying how language is, without making any kind of value judgment about whether that's good or bad. So you might have heard a prescriptive statement something like, is not is the correct form, and you should not say ain't. Ain't is wrong. You should say is not. Linguists have no time for that kind of thing. They are not interested in saying how someone should talk. There is no should in linguistics. Linguists are interested in making descriptive analyses of when someone might use the is not form or the ain't form, or in what context, or why, or how. They're interested in understanding how this occurs and in what situations. And so any form of a language that is used to communicate between people is valid. Ain't is just as valid as is not. They might occur in different situations, they might be used differently, but they are both equally valid insofar as all language is valid. Now personally, after studying linguistics, I later became an English teacher, so that's where you have to make a lot of prescriptive statements, especially if you're working with non-native language learners, or you're trying to help them understand, which is the correct form that a native speaker would use. But even so, you really quickly realize that there are perfectly valid ways of using language that might be used by, let's say, a huge group of non-native speakers. For example, there's a form of English called Global English that is largely used by people who do not speak English as their native language, but is nevertheless a perfectly valid form of the language. In any case, this is all to say that prescriptivism is something linguistics teaches us to avoid. And I don't know about you, but I've noticed quite a bit of prescriptivism going around the software development world. I don't know if y'all have ever been on the internet, but you will find a lot of prescriptive statements there. And this is nothing new. This has been happening for a long time. For example, in the mid-70s, this programmer named Dykstra, who I guess did some important things for the discipline, but also generally seemed like a very grumpy dude. I don't know. He made a bunch of horribly offensive and disturbing statements about various programming languages. He said that Fortran, super important language in our history, is an infantile disorder, that anyone who has learned BASIC is mentally mutilated. That learning COBOL, writing in COBOL at all, cripples the mind. These are unthinkable things to say. I don't even understand how we ever listened to this person. And then he says about a language called APL that it was just a mistake. A well-executed mistake, he says, but just a mistake. No. Just no, Dykstra. Bad Dykstra. No. This is not... We don't have time for this kind of thing. We don't have time to be making these value judgment statements about language. We have to be understanding that each of these languages, insofar as it was widely used and allowed humans to do useful stuff, is a good and valid language and deserves to be studied and appreciated for the problems that it solves well, or perhaps the time and place in which it was the best solution for those problems. So let's take a look at this last one as an example. APL is a mistake, he said. Have folks heard of APL? Okay, several hands. I had not heard of it until recently. Has anybody written APL? Okay, a few hands. Okay, very cool. So we can ask those folks who just put up their hands some more APL-specific questions. As I said, I just kind of came to understand that APL was a thing in the last year or so. And for folks who haven't heard of it, APL was a language developed by a guy named Kenneth Iverson in a book he put out called A Programming Language, APL. You only get to use that one time. And he was trying to explore how a particular notation, insofar as a programming language is a notation, could help us think about problems in a way that made it easier to solve them. And so he was looking at the problem of, okay, here I am, I'm trying to conceptually, theoretically solve this tough problem, so I'm going to do a bunch of math. I'm going to write out my solution in kind of academic math notation. But then, once I've got that solution, I have to translate it into code that the computer can run if I want to actually execute my algorithm. And so that translation problem is kind of hard, and then that means we have to think about the problem kind of differently using a different notation. So he wanted to come up with a notation that could be used as a tool of both thinking about the problem, reasoning about it, and running the solution on the computer in the end. And our first clue that Dykstra was super wrong about this, that APL was a mistake, from Kenneth Iverson's perspective, can it be a mistake if it won him a Turing Award? I don't think so. That's our highest accolade we have to give in this field, right? And so he was awarded the Turing Award in '79 for his body of work, but that was largely focused on APL and array programming languages that came out of it. And if anybody has seen APL before, you won't be shocked, but if you haven't, buckle up, because this is what he came up with for this notation that would help us both think about and execute our solutions to problems. It looks something like this. This is a program in APL, or in a dialogue is a sort of more modern version of APL. I have no idea what those symbols do. No idea. Won't stop me from putting them on my slides. But can anybody guess, even if you don't know what those symbols do, can anybody guess what this program is? Game of Life, exactly. This is an implementation of Conway's Game of Life in Dialogue, this version of APL. If folks haven't heard of the Game of Life, it's a simulation of evolution of these little living cell organisms where through different generations, you could say they live or die based on how many neighbors they have. So each of those little black pixels there would be kind of a cell, and in each iteration of this game, certain cells die, certain cells are born, certain cells just hang out. In any case, this is a type of problem that APL is really good at solving, because APL and the family of languages that it engendered are called array programming languages. They have a particular focus, or are particularly good at handling arrays and matrices. So problems that we can represent as matrix manipulations, for example, a grid of cells, are really well suited to solutions in APL or in array programming languages. And so that's definitely not a mistake. Matrix problems are a huge subclass of problems that are really important for us to have good solutions to. And one way that we can notice that this is something very influential and very important in our day-to-day is that today we have scientific computing languages like MATLAB and R. Has anybody used either of these? Okay, lots more hands. That were influenced by the family of array programming languages, which ultimately traces its roots back to APL. These are, I don't think anybody could argue, very useful tools, especially in the scientific computing world and in the data kind of processing world. And if these are allowing scientists and other people to do really important, useful work, how can the language that gave rise to the concepts that we find in those languages be a mistake? It certainly can't. One other fun fact, so another class of problems that's really well solved by treating things as matrices and doing matrix manipulations is in computer graphics. So if there are any graphics programmers out there, I'm sure you spend a lot of time working with matrix manipulations and linear algebra and whatnot. Another class, another great target for array programming languages like APL. And in fact, especially in the 80s when these things were kind of relatively new, there were quite a few folks doing graphics programming in array programming languages. And fun fact, fun trivia fact, there was at least one case, according to the internet, of a company using its implementation of APL to create visual effects for popular and beloved movies, such as Tron. There is a company who created some visual effects for Tron that did that work in APL, in their version of APL. So if you like Tron, you definitely have to disagree with Dykstra that APL was a mistake. Super cool movie. All right, now this is all to say that we need to understand languages not in these black and white, good or bad terms that Dykstra would have us believe, but rather we need to understand them in the context of the problems that they're trying to solve, and also perhaps the time and place where that solution was developed and the other tools that people had at their disposition at the time. And so Tomasello, in that same paper, Language is Not an Instinct, sums this up pretty nicely. He says, languages are cultural artifacts that differ radically among different cultures, as we can see in the Atlas of Language Structures earlier. And languages change in important ways as the communicative needs of their speakers evolve over time. So languages are there to help us do something, communicate. And in the case of programming languages, they're helping us communicate with each other about how we want the computer to do stuff, and incidentally, with the machine so that we can tell it what to do. And as those needs change, as we collectively as a community develop different needs, as our problems change, we're going to have to evolve our tools to match those needs. And so this all gets at this idea that is a really important one in certain subfields of linguistics, that we need to understand language in the wider context it exists in. For example, the field of sociolinguistics studies how language exists, not in isolation, not Chomsky sitting in an armchair thinking up sentences that may or may not be possible, but rather how language exists in the wider socio-cultural context. Language is something that we do as a human activity that is inextricably intertwined with all of our other human activities and all of the dynamics involved. So we can't separate language from dynamics of power and status, from notions of economic and political systems, from issues of race and gender and identity, from systems of religion and family dynamics. There is no way to separate language from any of those. It is deeply linked with all of those, and every other word that wouldn't fit on this slide, all of those systems. And make no mistake about it, insofar as code is a human activity, code is inextricably intertwined to all of these as well. And so what we need to do as a community of programmers and of computer scientists is consider our code in that wider social context. Another interesting field that considers language in context is pragmatics. So in the field of pragmatics, we're looking at the use of language. We're looking at how language is actually used to do things or to have kind of communicative actions in the world. And so what we quickly see is that words do not just exist in isolation in these kind of like Platonic ideal forms. They are things we do in the world. Every time I say something, I'm making an action. And I really need to consider not just kind of the textbook meaning of the words I use or what I had in mind when I used a certain word. I also need to consider what impact that action, that word that I'm using or that sentence that I'm uttering is going to have on the world around me. Sometimes that impact can be a negative one. The words that we use in our programs are no different from words that we use in human language. They are actions and they have impact as well. This is a tweet from a software developer named Kaya Thomas, who a few years ago was still in school. and mentioned that in her security class, there was a lesson where they were learning about white lists and black lists. Lists of trusted sources or certificates and lists of non-trusted sources. And this clearly, as you can see in the tweets, had a negative impact on her and as a person learning about this in this class. And evoked also to her mind the other very impactful and negatively impactful words that we use in code without really considering the wider context, things like master-slave analogies that we use when talking about systems. These type of words, all words that we use, whatever we name our variables, whatever we put in our documentation about our code, all of that is no different from any other human language insofar as it's an action and it has an impact. And we really need to be considering that when we name certain variables, certain things in our code base. Now, I already know what some of you are thinking. Some of you are thinking, well, okay, but that wasn't what I meant when I called the things whitelist and blacklist, and that's not even the etymological meaning, like the etymological origins of how we came to use those words, like that's not what it means, that's not what I intended. In the context of how language affects other humans, it doesn't matter. It doesn't matter what the etymology of these words is. It doesn't matter what your intention was when you named your things in your program was, if you even had an intention, if you were even thinking about it. And the thing is, we have such simple ways we can make these type of names for variables and whatnot better. For example, we could use words like safe list and block list, which in addition to being one character shorter in one case, because programmers are obsessed with how many characters long things are, actually, to me, is a much more self-explanatory name for what we're trying to do here. A safe list is a list of safe things. A block list of things I'm going to block. There's even a little bit less processing involved there because you don't have to be familiar with the usage of these terms whitelist and blacklist. And likewise, leader and follower can convey exactly the same relationship in systems and not have the negative impact of words like master and slave. There's no reason for us to still be relying on these outmoded words that have, if any impact, a negative one, when we could make these small changes and really consider that every line of code that we write is a human artifact that exists in a human context. We can't separate that out. We can't pretend that just because we're talking to machines, and remember, we're talking to each other, actually, we can't pretend that just because the machine doesn't have notions of society and power dynamics and whatnot, that it doesn't matter what we put in our code. It matters. And in the case of a classroom where we're teaching the next generation of programmers how to exist in this world, it matters even more. We should be all the more attentive to the assumptions that we're making and the impact that our sample texts, our sample code bases, our introductory texts, and all of that stuff involved in trying to teach coding, we have to be even more attentive to the cultural context that surrounds it. This is summed up really nicely by a programmer named Ramzi Nasser. He says, if we're going to teach programming around the world, we have to be aware of what the cultural biases are. Now, we said that insofar as code and language give us the power of collaboration, they allow us to do amazing things. They allow us to change the world the way that we want to. And insofar as they have that immense collaborative power, and so far as code, the ability to code, gives us that power, we really need to be sharing that power. We need to be teaching it to everyone. And if we're going to be teaching it to everyone, we have to understand that everyone has a different kind of ground assumption of how language works, which is going to influence the way they understand how code works. For example, almost all of the introductory programming examples that I can think of, and languages that are generally considered kind of beginner-friendly languages, make the assumption that you're used to reading a Roman alphabet, reading left to right, etc., etc. That might not be the case if you, let's say, speak Arabic and come from a right-to-left language background, which doesn't use a Roman script. And this was the problem that Ramzi Nasser was trying to solve. He was trying to find a way to help, especially children who are Arabic speakers, learn code without having to surmount the additional hurdle of understanding a different alphabet and reading text in a different direction. And he created a language called Alb that was intended to be an Arabic kind of learning language or teaching language to help folks from that linguistic background understand how computers work before they already have to tackle the linguistic problem. And that inspired another programmer, Ahmed Abdallah, to create another beginner-friendly teaching language in Arabic called Noor. Noor is typologically different from Alb, Ramsey Nasser's language. Alb was a more functional Lispy type situation, and Noor is more imperative. And this is what we need to be doing. We need to be creating these new options. We need to be giving folks options to learn how to code and learn different paradigms of coding in their native language without already having to struggle with the English words if, then, and while, and whatnot, and without having to deal with a different script. And so this type of work I find incredibly important. Insofar as we need to be sharing that collaborative power with everyone, we need to be re-examining our assumptions when we're trying to teach people code. And that's because, just like human language, code is a language that we are not born speaking. We do not come out of the womb fluent in Shakespearean English or Twitter vernacular or any of the above. We learn language gradually, usually as children. And in the same way with code, none of us off the bat knew how to program. We all learned it gradually. And we learn through context. So when we learn natural language as children, we don't learn abstract words like cat and dog. We learn them in the context of like, there's a cat and there's a dog, right? We learn them with other cues, visual cues, social cues, all kinds of other context that helps us acquire that language. And yet, when we go try to teach people programming, we give them stuff like this. We name things foo and bar and baz, none of which are words that have any really meaning. In fact, bar is a word, but this doesn't have any of its usual meanings here. So what we're asking people to do is kind of learn without any context around what those words actually mean. Now, when true story, I was learning Python, right? Didn't have a background in computer science, and I had one of these like intro, Python programming books, and there were all these examples being like foo, bar, baz, and I was flipping back to the beginning of the book, being like, did I miss somewhere where they said what a foo was? Like, where did they introduce that concept? What is a foo? It was really confusing. And I can't be the only one. How much easier would programming learners have it if we used words that meant things? What if we replaced all of our foos and our bars and our bazes with words like, okay, the result is the thing that happens when you analyze the data? So this is one thing I think it really behooves us to, in our documentation, in our examples, or when we're trying to explain to somebody how something works, to not use these abstract terms, but to actually put them in context, even if that means we have to spend a couple extra cycles figuring out an appropriate context for this beautiful, elegant, abstract construction that we've made, because guess what? Doesn't matter unless people could actually use it to do real things. So, okay, that's my little tirade. Now, the next interesting thing about human language is that we learn it out loud. Most of the time, not always, but most of the time, we learn language by hearing it and speaking it. And this is something that's really interesting when it comes to programming, because we don't necessarily talk a lot about the auditory or the oral aspect of learning to code. I'm going to play a little game right now. Okay, everybody turn to the person next to you. Say hi. 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 Okay, now, on the count of 3, I want you and the person next to you together at the same time to read this line of code out loud. Okay, ready? 1, 2, 3, go. I heard, okay, raise your hand if you said the exact same thing that your neighbor said. Like 1, like 2, 3, 4, a few hands, but the majority of people did not, right? And that's because we have no canonical way of pronouncing code. You might say result equals analyze data, maybe, but you might also say something like set result to, and then you might use the of to indicate the function application and say analyze of data. Or you might even explicitly call out that data is a string, so you might say analyze string data, and you might read in kind of the way the program would execute it, so analyze string data becomes result. Who knows? Or any of a million other ways of pronouncing this. There's no canonical form. And this is a really interesting area of investigation that a computer scientist named Feline Hermans has been looking into recently, asking the question, can we really comprehend and communicate source code if we can't agree on how to vocalize it? And in her group's preliminary investigations into what she's terming code phonology, they're finding that there's a relationship between programming skill and the consistency with which you pronounce source code. The convention doesn't exist globally, but within individuals, the more experienced of a programmer you are, the more consistent you're going to be in how you pronounce any particular piece of code. And interestingly, they're exploring the idea that we might also be able to understand what types of syntax are easier or harder for learners to comprehend by understanding how easily they can decide on a way to vocalize that code. Really interesting area of investigation, if you ask me. I have some citations in the slides if you want to read more. So the last point that I want to talk about here, as we've only got a few minutes left, is one of the most interesting things, I think, from the area of language acquisition, is that it might sound obvious, but humans do not learn language alone. Obviously, it's very difficult to study this ethically, scientifically, but in the few instances where humans have not had any human contact as children, they do not learn language. We can't invent a language by ourselves. But even if we have one or a couple of other people around us, we can come up with some way of communicating and therefore collaborating. And the same is true of code. None of us are self-taught programmers. I didn't have a formal education. I learned from books and other resources and things like that. But I didn't learn alone. Some human wrote that book for me to read. And some other humans posted answers on Stack Overflow for me to read and learn from. I learned in a community. And we all learn in communities. And so it really behooves us to invest in those communities and make sure that we're paying attention to the collaborative way we can help people learn and the collaborative way that we as a discipline can advance this thing that we do, this crazy coding invocation discipline that we've come up with. So some of the communities that I learned from that were absolutely valuable and indispensable to me along my coding journey, one's called the Recurse Center. This is a self-directed programming retreat in New York City. If you haven't heard of it, highly recommend you check out recurse.com. It's a space and most importantly a community where you can go and get better at coding, whatever that means to you. No classes, no teachers, completely self-directed, self-organized, but with a community of other people doing the same type of curious investigations that you are to help you learn. Another community that I am so grateful for and love to tell everybody about is a program called Outreachy. This is an initiative to get more women and underrepresented minorities involved in open source by offering paid remote internships at organizations that run big open source projects. So for example, I interned at Mozilla working on some of their awesome open source projects. And what this is a great way for folks to get that entry point into open source where they don't just have to jump into GitHub and start posting on tickets in a community that they don't know and have no way of getting to know, but rather they have a dedicated mentor on the project to help them get started. Really great initiative. If you might be interested in working with an intern, if you work on an open source project, or if you or somebody you know might be interested in a paid, full-time, remote internship, check out outreachy.org. And now, as a professional, I work at a company called Mapbox, where I am engineering, learning, and development lead, as well as a software engineer. And this is a role that I have because we, as a group, as a community of colleagues, we want to be learning all the time. We want our work and our growth as programmers to be inextricably linked. And so we do that by relying on each other to constantly mentor each other, pair with each other, explain things in very clear terms. We have a rule, no dumb questions. We even had a little Slack bot that when somebody says, this is a dumb question, it says, there are no dumb questions. And so if that sounds like a cool place to work, we are hiring. Check out mapbox.com careers, but it's not a plug. What I want to say is make sure when you go back to the communities that you work with every day, whether that be in a professional sense, at your job, or whatever community you find yourself in, make sure that you all are appreciating how necessary that social bond is between you, without which we couldn't advance as individuals or as a community. So that's the thought I want us to leave with. And I hope that at this point we've kind of had a chance to reflect on some of these big picture ideas, to see that code, insofar as it is a human communicative activity, is a type of language. And just like human language, it is a tool for collaboration. And the reason that that is important is because it is only through collaboration that we, puny little humans, have any power at all. So what we need to be asking ourselves then, and what I hope we can kind of have as a continuation of this as we go back and think about the other talks and talk to our neighbors at the conference and talk to our colleagues back home, is given that immense collaborative power that code affords us, what are we going to do with it? Thank you so much. Thank you so much, GOTO Chicago, for having me back here. And I have a bunch of references up here on the slides on Speaker Deck if you want to look more into any of the fascinating studies and whatnot that I mentioned. And thank you all so much for listening.